Let me start recording. So good evening, and I will say happy Valentine in arrears. I hope you had some good time yesterday with your loved ones, and I want to also thank you so far. I know you've been working very hard to cope with the pressure of work as well as joining the lectures. Some of them fixed during your working hours and also fixed during your off working hours, making rest a very important task. Please mute yourself. Who is that? John Bosco. Mute yourself. So I guess you know the courses you're to offer and the courses you're not to offer, and also want to be sure you have made up your mind on the option that you want to take in this program. Are you still having issues deciding on the option you want to take and the courses that you want to specialize on? You know, we have 4 different option areas. We have risk, we have livelihood, we have geographic information system, we have climate change. And also, you should also be aware of the courses that you are to offer. I want to take 5 minutes to run through our handbook. Somebody called me not too long, expressing worry about the courses to offer, and perhaps may not have understood the content of the handbook. Is that the case with everyone?
No, it's not.
Is that the case with?
No, sir.
It's not.
No, it's not.
But sir, I actually have issue. Hello, sir.
I'm hearing you. Go ahead.
Okay, I actually have issue with respect to these elective courses. Are we to take the 2 electives or we have to choose?
Let me see if I can upload the handbook. Well, the electives is a matter of choice. If you have interest in that course, you can consider it as elective. Whether you pass it or you fail it, you will be able to, you will graduate. But however, there are courses, mandatory courses that you must, courses that you must pass. Okay, let me see if I can.
Okay.
Let me see if I can.
Okay.
How do I expand this? Let me see if I can.
Handbook for postgraduate programs.
Okay.
The lecture started already.
Now we have that guy should mute. Let me see if I can have a full.
Okay, can I play?
Please lower your voice. Who is that? Now we have. Are you seeing the slides?
Yes, sir. I'm doing it. Yes, sir.
Now let me see. General requirements. This thing is not moving the way I expect it to move. Now, if you look at this is for PGD. Okay, let's move straight to the postgraduate. Now, candidates will be required to register for a minimum of 24 units. PGD diploma. No, let's move over to postgraduate diploma. Let's move over to masters. Now, this is masters. Are you seeing the unit? Are you seeing the slides?
Yes, sir.
Okay.
Yes, sir.
How do I move? Now we have this option areas. We have livelihood and environmental resource management. We have environmental risk assessment and management. Okay. We also have geographic information, environmental information system. We also have climate change. We have 4 option areas. You can't run two options at once. What you do is just one. You decide on the option that you want to run and now offer the appropriate courses. Now, but as a general rule, every student must register a minimum. Let me color it. Will I be able to color it now? Where is the color? A minimum. Where is it? A minimum. A minimum. I don't want to do something that's a minimum of 24 units of taught courses made up of core courses. So in essence, you must offer up to 10 units of core courses in your specialization, in your area of specialization. Is that clear?
Yes,
Is
sir.
that clear?
Yes, sir.
Then, yes, and specialization. Let me see if I can remove this so we can see very well. Now, specialization to be offered in 2 semesters respectively. So you can decide to run 5 units, but you have to offer minimum of 26 units, 24 units. Okay, minimum of 24 units. Now, if you look at, in addition, and during the second or third year, students must register for and earn credit units of the certification, 6 credit units of the certification. So in essence, 6 plus 24, we expect you to run up to 30 units. Dissertation or thesis, 6 units, and 24 units of what? Of courses or taught courses. You understand what I'm saying? Is that clear now?
Yes, sir. It's clear.
This thing. It's clear. So now, if you're running livelihood, these are courses you need to offer. You have to offer all these courses. Then for these 2 elective courses, it's a matter of choice. For these 2 elective courses, it's a matter of choice. You can take 2, you can take 1, but you must take 1. If you like, you can take the 2. Now, if you are doing environmental risk assessment, these are the courses. Remember that you cannot drop core courses in your area of specialization. You cannot drop what? The core courses. You must do them. All these core courses, core is compulsory. We also went as far as defining what core. Who is making this noise, for Christ's sake? You also you must do all the core courses. For these other people in risk assessment, and you can do these 2 courses, you can do these 2 electives, or you choose one. But however be the case, at the end of the 2 semesters, you must have offered up to what? 10 core courses, and total unit must be up to 24, including your dissertation, that is including your thesis, will now make it 30 units. And for geographic information system, this is the courses that you are to offer. For climate change, these are the core courses and electives. Okay. The rest semester, the same thing, and so on and so forth. So there is nothing to be confused about. Read through this thing, know the total units you ought to offer, and please offer them. Don't let anybody, because anyone that you fail to write the exam, you're coming back next year to offer them, and that is not to the interest of anybody. Is that clear?
Yes, sir. Very much clear.
It's okay, good. Thank you very much. So I want to thank all of you for participating in the test. The test that we did last time after our lectures. A good number of you did very well. I appreciate your participation and also your performance. Okay. I appreciate your performance. So today we'll make progress. We will look at another topic. Last time we were able to look at a situation where we have unknown standard deviation in the problems. Standard deviation is given, and we're able to have the standard deviation as well as the mean, Let me see your face, see what you can see my face. So today we are going to look at a situation hypothesis testing when we do not know the standard deviation as well as the population mean. So we'll go extra mile to determine the population mean, and now before we'll be able to test the statistics and test our hypothesis. So let me share my slide. Are you seeing the slide?
Yes, sir.
Yes, sir.
Okay, good. Let me enlarge the screen so you can see the slide now. Now, I said today we are looking at hypothesis testing about unknown population mean. We don't have the access to the population mean. We don't have access to the population standard deviation. So last time we were able to test the hypothesis when the population mean is known, and also when the standard deviation of the population is also given. So the outline, we are concentrating on hypothesis about the population mean when the population standard deviation is unknown. Now, we believe that at the end of this training, the learning objective is to make sure that every participant today will understand how to test hypothesis when the population mean is unknown. So we believe that all of us will understand the test statistics, the procedure, and how to carry out this arithmetic, how to carry out this hypothesis testing when we do not know the population standard deviation. Now, frequently, the population standard deviation is not known. Take, for instance, the example I gave you about photo students. There is no way we can determine or have access to all the students' population to enable us take decision on the student. So normally we have to carry out sampling. We have to conduct sampling, and from there we'll be able to take decision on that. So most often, standard deviation of the population is not known. So we need to estimate the population standard deviation from the sample. From the sample, we'll be able to estimate that with the sample standard deviation. However, the test statistics will no longer follow the standard normal distribution that we used to know. The test statistics will no longer follow the normal distribution. We must rely on the students' t-test distribution. Students' t-distribution. We will now have to take the degree of freedom number of sample minus 1. Of course, you are aware of this word, degrees of freedom. We know the distribution table, as well as making sure that the sample size is always subtracted. 1 is subtracted from the sample size. Because we use the sample standard deviation, the test statistics will change from a z-score to a t-score. We won't be using p-value, we won't be using z-score, we will now be using t-score instead of the z-score that we use when we know the population standard deviation. Now, we are aware of this particular z-score model, this equation, mean minus sample mean minus population mean all over population standard deviation all over square root of sample size. We will now move over the t-score over sample mean over population mean all over sample standard deviation over the root of the sample size. Steps for a hypothesis test are the same that we have covered previously. What are the steps? You must what? You must decide on the critical, who is this fellow? I'm tired of this, your class and behavior, honestly speaking. I'm obviously tired with this class and their behavior. We've never had it so bad like this before. We've not had it so bad. Honestly speaking, I must be frank with you people. Steps for a hypothesis test are the same that we covered previously. What are the steps? Remember, we normally construct our null and alternative hypothesis from known to unknown. Null hypothesis is what you want to dispute, the test, what is known, and the alternative hypothesis is what you are testing to be true or false. Now, you must also state the critical significant level, the level of significance. Is it 5%? Is it 1%? And so on and so forth. We normally refer to it as the critical value. Then thereafter now, we now use this model to compute our test statistics. From this test statistics, we go into the table and now take our conclusion, state our conclusion. So this is the critical procedure, whether you are handling it from the point of view that you know the population size, population standard deviation, or when you do not know the population standard deviation. These are the standard procedures. First, you must construct your null and alternative hypothesis. We have dealt with it. I hope you know how to construct the null from the question or from the hypothesis, from what you want to test. You should be able to state the null and alternative hypothesis, as well as also deciding your level critical value. Is it 5%? Is it 1%? Remember that it cannot be more than 5%. Anything more than 5% means that you are giving very high opportunities to error, and your confidence level is shaking. Your confidence level cannot be relied upon. Okay. Now, from there, we will now use this model, whether it's Z-score or T-score, to compute our test statistics. From the value we obtain from our test statistics, we will now take it to the table, the normal distribution table or the T-table, T-distribution table, and know whether it is higher in the rejection zone or acceptance zone. From there, we will now take our decision. That is the procedure. Now, just as with the hypothesis test from the previous session, the data for this test must be from a random sample. Remember, all laws or hypotheses in statistics are drawn from random sample. Without random sample, that particular model cannot hold in statistics, and requires either that the population from which the sample was drawn be normal, or that the sample size is sufficiently large, is greater than 30. Sample size is greater or equal to 30. So a t-test is robust, so small departures from normality will not adversely affect the result of the test. So that being said, if the sample size is smaller than 30, it is always good to verify the assumption of normality through a normal probability plot. I don't have a pen here, but now you have to plot it to see that the distribution within the assumption of normality is obeyed, that is equally distributed with a mean, and mean error is equal to 0. They are equally distributed. Now, selecting the correct critical value from the student t-test distribution depends on 3 factors. The type of test, is it one-sided? The issue of one-sided, two-sided, we have dealt with. Now, the sample size. Does the sample size obey normality? And the level of significance. Is it 5%? Is it 1%? Or you can even have 0.1% critical level. No, for a two-sided test, not equal or not equal alternative hypothesis, the critical value must be divided by 2. Alpha must be divided by 2. It's determined by alpha. But for one-sided test, you don't need to divide the critical value by 2. The level of significance divided by 2 to deal with the probability that the result could be less than or greater than the value, known value, the value that you're testing. If your level of significance was 0.05, that is 5%, you will use the 0.025 column. Thereafter, we will move to the T distribution table so that you look at the table, you look at the columns. We have 0.05 column, we have 0.025 column, and so on and so forth. So whichever the column that the critical value that you have, we check out the value there to find the correct critical value. If you are using 5%, you divide by 2. For a two-sided test, if your level of significance was 0.01, you will use the 0.005 column, because you are to divide the critical value by 2. This is very simple. We should understand it depending on the test statistics, depending on the question, whether you're dividing, whether it's one-sided or two-sided. Remember, the example we have been stressing on is for two-sided tests, vis-a-vis the critical level, whether how we divide it to get the column we will read out and compare with the test statistics. Now, for a one-sided test, a less than or greater than alternative, like I said, we don't need to divide. The critical value alpha is determined by what? Alpha. The level of significance being all in the one side. So if your level of significance was 0.05, remember 0.05 is 5%, you will use the 0.05 column to find the correct critical value for either a left or question. If you're asking a less than, that is left-sided question, your critical value will be negative. Remember, you're not going to divide. If you're asking a greater than, a right-sided question, your critical value will be positive. It's very simple. We've been discussing it. We've been looking at it previously. Now, let us take one example. Let us take one example here. I think. What will I? Okay, let me check with that. And this to move away from here. Okay. Now, find the critical value you will use to test the claim that population mean equals to 115 with a sample size of 18 and a 5% level of significance. 5% level of significance. In this case, the critical value alpha will be divided by 2, would be 2.110. This is two-sided question. How do we look at it? How do we look at this? Now, let me drop this and share. Let me drop this and share the critical value. Remember, 0.05, this is the sample size. Remember, we check the critical value, this 5% under, it's not going to be 8 again, it's going to be 17 because n minus 1, sample size is 18, minus 1 is 17. So when we divide 5% by 2, we are going to have 0.025. We will look at 0.025 under 17. Let's look at, let me come here and hide this. Then let me add upload. Let me upload the Are you seeing the table? Are you seeing the table now?
Yes, sir.
You are seeing the
It's
table.
tiny.
Sorry. Are you seeing the table? This is the distribution table. Okay. You say you're not seeing it.
No, sir, it's tiny.
What are you saying? Are you are seeing it? You are seeing the table, right?
Yes, yes, yes.
Okay,
figures
good.
are
Perfect. You said I should save your time.
No, I said the figures are tiny.
Okay. I did better
Thank
now.
you, sir. Yes, sir.
Better, right? Better. Now, if you
Yes,
look
sir.
at the vertical, if you look at If you look at the vertical line, you will see 0.025 because we divided 0.05 by 2. That's when we are getting 0.025. Have you seen it? Now, if you look at the degree of freedom column, the vertical column, and you go over to 17, remember the sample size is 18. 18 minus 1 will give you 17. So you trace this 17 to where you have 0.025. This becomes the real actual critical value, 2.110. Is that clear? Is there any confusion about it? Eh?
No, sir.
No, sir.
No, sir. It's clear.
Okay, good, very good. Now let's continue. Let me go back to okay. Now this is the question we looked at. Are you seeing the screen now? I screen the screen. So we now have 2.110. You see how we got 2.110. Let me put it up in a better way. Now you will now see how we have alpha equal will be 2. This value is what we are going to compare with the test statistics when we are done with the calculation. Now, another example for one-sided. What will be the critical value? What will the critical value be if you wanted to test that population mean is less than 112 for the same data? Remember, we use 5%. Is that clear? We use 5% and n 18 equals to 18 sample size. What do? We don't need to divide the critical value again by 2. This is what we did here. Instead of looking at 0.025, we look at 0.05. Let me quickly go back there so that you will understand what we are talking about here. Have you seen what we are talking about? This is 0.05 column. We were not looking at 0.025 column. Rather, we are looking at 0.05 column. Come back here, you will see 17. You read out 1.740. Is that clear? Are you following?
Yes, sir. Yes, we are.
Okay, good. Yeah, good. Perfect. Thank you very much. Now, let's quickly go back to our now that is it. So we'll move on. We know how to deal with when it's sided, deal with the critical values, when it is two-sided, when it's one-sided. Now, for a two-sided test, example 1, in 2005, the mean pH level of rainwater in northern Nigeria was 5.41. The biologist believes that the rainwater acidity has changed. It has changed. He doesn't know. He didn't say that it has increased or it has reduced, but it has changed. So it's two-sided. He takes a random sample of 11 rain dates in 2010 and obtains the following data. Use a 1% level of significance to test his claim. See whether who is that? See whether this 5.41 has changed, whether it has reduced, whether the pH level has reduced or has increased in value. Now, this is the data he collected from the field. That is why right now it's only from this sample that we'll be able to estimate the population mean, get the sample mean, and the sample standard deviation. Okay, we will now go back to that formula I showed you at the beginning of this class. Now, the sample mean is 5 points. Sample mean, if you add up this, of course, you know how we get the sample mean. 4.7 plus 5.63 plus this to 5.01 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, divided by the 11 random sample. So at the end of the day, you're going to get this value, 5.343. If you look at 5.343 plus 5. Of course, we think that what? Actually, it has reduced. But there's only statistics will tell us whether actually this difference is significant or not. Okay? Now, how do we go about it? The sample mean is this with a sample standard deviation. Sample standard deviation using the formula SD. Wow, it's not there. There is a formula here. Let me go back and check to get you the formula for standard deviation, how we'll get it. It's supposed to. Let me exit this and check whether I'll be able to get the formula for standard deviation. It should be here. It should be here. Uche, me check I'm in a meeting now. I'm in an online meeting. Now, now you will see the wow. Why is it not showing up from here? Why is it not? Why is it not coming up? Please. Why is it not showing? Is there the? Why is it not showing here? The standard deviation is here. Why is it not? Well, when you is not showing, I don't know why this particular LMS doesn't allow the formula to pass here. But I think if you if you open the notes I sent to you, is there. I don't know why. If you want to upload it in the LMS, the formula goes off. But rather, the formula is summation is, we call it almighty formula. Summation x minus mean all over square root minus n minus 1. I don't know. Somebody will help me download the note for this particular lecture and confirm that that particular standard deviation formula appears. But this time I want to upload it in this element.
So it's there.
Is there,
there on
right?
the note.
Is there in
Yes.
the note? Oh, perfect.
Yes,
Good. Thank you very much.
Yes.
Thank you very much. But it goes off here. I don't know the problem. Now, since you've known how to calculate the standard deviation, so what else? You will now construct your null and alternative hypothesis. You construct your null and alternative hypothesis. Now, look is what is known is 5.1. And we say that we don't know after how many years of rain, after 5 years of rain, and we took 11 samples, and now we want to find out from that sample, alternative hypothesis is not equal to, but the mean value is showing 5.343. We have to subject it to statistical tests. Now, we state the level of significance. We say we will have what? 1%. Remember, the question says we should use what? 1%. Now, is there any problem? Any question? Now, the question says we should use 1%. Are we to divide that 1% by 2 or not to divide it by 2? Somebody should tell me. Are we to divide that 1% by 2 or not to divide it by 2?
Yes, sir.
We
Yes, sir.
divide it by 2.
Yes, sir.
Right. Very well. Very well. Thank you very much. Now, if we divide the alpha by 2, we are going to have, we want to check at the column of 0.05 column with 10 degrees. Remember, we have n equal to what? 11. Okay. We have n equals to 11. N minus 1 will give us what? 10. Let's quickly look at the table and see what we will have. Now, if we have 11, remember we divided it by 0.01%, 0.01 will give us 0.005 under 10. What will it give you? Under 10, what will it give you? 3.169. Okay? 3.169. $3.169. 3.169. Have you seen it? Now, having known, we've gotten all the things we need to compute the test statistics. Now, we will establish our formula. T equals mean minus population mean over standard deviation square root of what? N, sample size. For this problem, the test statistics is what we have, the mean, sample mean that we have 5.343 minus the population mean, the value we already know, all over the standard deviation that we already calculated. If you look at the standard deviation, we already have it there. The standard deviation, if you calculate it, if you look at what we calculated, if you substitute that particular almighty formula into it, you're going to get 0.397 all over n. All over n. All over n. Let me enlarge this so that we'll be able to all over n. Now, at the end of the day, we are going to get minus 0.560. Now, state the conclusion. Compare the test statistics to the critical value. What did we get as the critical value? We got critical value to be what? 3.169. This is the critical value we got to be 3.6, and we are getting this one to be 0.560. Now, for a two-sided test, when alpha is equal to 0.01, the test statistics does not fall in the rejection zone. Look at the hyperbola curve. This is the rejection zone, and this is the acceptance zone. Failed to reject, non-acceptance zone. This is the rejection zone. Now, this is the test statistics, 3.16, 3.169. If move this way, you find out that this is 0 here. It's go here 0.156. This is what is calculated. So the test, we fail to what? Since it falls, we accept the null hypothesis. That was, we fail to reject the null hypothesis. Rather, we accept the null hypothesis. We do not have enough evidence to support the claim that the mean pH has changed. Remember, we said, has it changed after so period of time? During we now took our sample. So 5.343 is against 5. What it used to be 5.4 something. That cannot be regarded as change. So we accept the null hypothesis and conclude that we don't have enough evidence to show that what the pH has actually what changed. So it's still the same, irrespective of the fact that there is differences in their mean values between this space of 5 years. Because the first experiment was conducted 2025, and this recent one was 2010. So the difference in the mean values of pH cannot be regarded as change. We regard them statistically as the same. Now, let us look at another example. Cadmium, a heavy metal, is toxic to animals. Mushrooms, however, are able to absorb and accumulate cadmium at high concentrations. The government has set safety limits for cadmium in dry vegetables at 0.5 parts per million. That is now the acceptable the acceptable limit for cadmium concentrations in vegetables. Biologists believe that the mean level of cadmium in mushrooms growing near strip mice is greater than the recommended limit of 0.5 parts per million. We believe that mining activities is there going on there. It must have increased, but we are not sure. Now, negatively impacting the animals that live in this ecosystem. A random sample of 51 mushrooms gave a sample mean of 0.59 parts per million with a sample standard deviation of 0.29 parts per million. Use a 5% level of significance to test the claim that the mean cadmium level is greater than the acceptable limit of 0.5 parts per million. This question is still in line with the other one, but however, the examiner here made things simpler for us. We're not going to use the almighty formula to determine the sample standard deviation. That has been already given. We are not going to calculate the mean, sample mean. That has also been given. Hope you understand what I'm saying. Okay, the sample size is greater than 30, so we are rest assured that it obeys normality distribution. So we're not worried. As against the other sample size 11, which is not up to or equal to 30, we would have tested, for us to be sure of that previous example, we would have tested for normality. Okay, in real life situation, we would have subjected it to normality test to be sure that it obeys normal distribution. So, do you think you will be able to answer these questions with ease? So let us look at the solution. First, state the normal and alternative hypothesis. Remember, this is the permissible limit we regard it as the population mean, 0.5 parts per million. And now we expect that since there is mining activity going on there, there is no how that the cadmium must have not increased, must have increased. The cadmium concentration must have increased beyond the permissible limit. Now state the level of significance and the critical value. This is a right-sided test because we are looking at greater than. So alpha is all in the right tail. What is the critical value here? I think it's 5%. They said we should test it using 5% level of significance. So it's 5%. So we make progress. Now, T alpha is found by going down the 0.05. We've gone through this a number of times, so you should know where we get it. Then this is 50 degrees degree of freedom. How do we get this 50 degrees of freedom? Remember, we said they collected 51 samples of mushroom. So 51 minus 1 will give you 50. So we check 0.05 under 50. What we are going to get, if you go there and can confirm, we have 1.676. Then we compute our test status. Since we have every other thing ready, so we have our mean, sample mean minus the population mean all over. Remember, the sample mean has been given as 0.59 minus 0.50 over the sample standard deviation all over square root of n. We got 2.216. State the conclusion. So let's look at remember this is 2 point, the calculated is greater than the tabulated. So we normally, the test statistics falls in the rejection zone also. So like fall in the rejection to the calculated. So we are going to reject the null hypothesis and accept the alternative hypothesis. We will reject the null hypothesis. We have enough evidence to support the claim that the mean cadmium level is greater than the acceptable safe limit. But what happens if the significant level changes to 1%? Remember that we use 5%. We gave a lot of chance to error. But if we tighten up our experimental procedure and make sure that the confidence of our experiment, we put it at 99%. If that is the case, the critical value is now found by going down the 0.01 column with 50 degrees of freedom. The critical value now is 2.403. The test statistics is now less than the critical value. So which means we can reject that the test statistics does not fall in the rejection zone. So we now say that there is no difference between the permissible level and the value of cadmium that we got. So this is, I want to tell you the role critical values, the significant level plays when we are determining when we are carrying out this kind of test, especially when it has to do with human life or risk to human being. Now, when we have reduced the level, critical level to 1%, we will now say that there is no difference between the two. There is no difference between the two. So what if there is actual difference? So that is why we said we are prone, if we don't set our critical level, significant level very correctly, we may fall in the risk of committing type 1 error. So this is where we'll draw the curtain for today about calculation of test statistics when we know when the population standard deviation and the population mean are unknown. So if you ask, before we now move over to analysis of variance and in our next class, the lesson 3, we will deal exhaustively with all the analysis of variance, the one-way classification, and the two-way classification. We'll try to pick examples there, and so before my colleague will now come and handle you on chi-square and other non-parametric tests, non-parametric, and now solve some questions, and then we can do joint tests so that we'll see how we can grade you on this particular course. Please, I also want to encourage you to go back home and practice most of these sample questions. The questions are not going to be far from all these sample questions that you are familiar with. It's for you to go through it, understand how they are solved. That will help you do well in this particular course. Don't just throw them away. Don't think that it's not something that you will understand. I will encourage you. Remember, it's a core course. It's a course that you must pass for you to graduate. So if you have any questions, please ask your question. Well, the quiz will come when I finish the lesson 4. By the time I'm done with analysis of variance, the experimental design. So you do the test together. So if you have any question, you ask. Do you have any question?
Jesus, I look max. Let me see.
Do you have any question? I'm rounding off. I just came in from Abuja this evening, so I'm tired. So I just, because I missed this class yesterday. Yes. If you have any question, please do ask. Otherwise, you
Prof,
prepare.
I have a question.
Oh yeah, go ahead, please.
Okay, please, when do we know when is a z-score or a t-score? When do we know the difference when a question is thrown?
Okay, now, like I said, T distribution is you manage when you sample, you're not using the population. You use the T distribution when you now sample out of the large population. When you sample out of the large population, and the population size is typically less than 30 or equal to 30. Okay, that's when you now know that you're going to use a T distribution table to determine, to test the statistics. And most often, like the first example I gave you, you need to now determine the sample standard deviation and determine the sample mean. So the sample is handy. You'll be able to manage the sample. That's when you use the T distribution.
Okay, thank you, sir.
Is that understood? Most of the questions previously we deal with population. You deal with population mean. So it is Z score. You now use your z-score to determine the p-value, to determine the test statistics. Do you have any other question? My colleague will be coming. Yes, Miriam Uchendu.
Good evening, sir.
Please ask. Good evening.
Thank you very much, sir, for the lecture, sir. But I still don't understand what z-score means.
Well, that is a statistical term. Z-score is a statistic. It's not like you're asking me what is t-score, t-distribution. It is those days we are using 4-figure table. You say, what is the meaning of 4-figure table? It's a test statistics. It's a table, normal distribution table, and it's used to test hypothesis.
Okay, thank you very much.
It's a table that you use to enable you answer, questions on your test statistics. It's used as a statistical table.
Thank you very much, sir.
It's all right. Please take your time to read the notes. The notes are very explanatory. If you read them once and you don't understand, please read them a second time. You should be able to understand them. Send all the things. My colleague will be coming as soon as I'm done next week. I will have a class next week with people, even on Thursday, so that I'll round off so that he can come and complete his own section while I move over to 801. Are you done with Professor Mrs. Njoku on 801?
No, sir. No.
You've not finished. You've not finished with her. So immediately she's done, I will come over to conclude my section on 801. So if you don't have any other questions, I encourage you to go through these two examples. Remember, we have done examples when the population mean is known, when it's given, okay? And now now we are talking about when the sample mean is not given and all that. So you know the two, you know how you address it and test statistics. Next week we'll be moving over to a more critical aspect of this study, knowing how we design our experiments, knowing how we test it using models, ANOVA, and how when we have array of parameter variables to deal with, we need to partition them, get the mean, and compare the means obtained in the experiment and be able to interpret them. So next week we will look at that, and I will conclude my section, then his section, and take more of the non-parametric data. He will take you on chi-square, he will take you on regression, he will take you on other aspect of statistics that will help you run your, do your research and to interpret the data. So,
okay, sir, please.
In absence of any other question, yeah, go ahead. I want to say something.
Please, sir, please, sir, I want to understand the precision of this evaluation, the precision, and to what extent can it help us to achieve a result?
I don't understand. You say you want to understand the perception of this training, this
the
precision.
This yes, the precision. To what extent? Yes, sir.
Wow. Precision in terms of what? Why the rationale for this topic, hypothesis testing? Is that what you mean?
Yes, in terms of how can it help us to achieve a result and to know.
No, this particular thing is, take for instance, you're giving a sample. So like the questions we raised, okay, take for instance, the last problem we solved, let's look at the last problem. It can come in real life situation, okay? Let me check. Okay, sorry. Look at the question of, maybe you're working in an office and or even you're doing an experiment. Look at this question. It can come in any way, even in your house. You will be able to test this. Somebody said that there is heavy metal is toxic to animals. You understand? Cadmium, a heavy metal, is toxic to animals. That is established fact. Okay, yes. And mushrooms, however, is not toxic. Cadmium at this level is not toxic to mushroom. They grow there because they are fungi. They have enzymes that can absorb, store them in their hyphae without noticing any impact. But once animals eat this mushroom, it bioaccumulates and exert influence on them. You understand me? And government has set safety limits for cadmium in dry vegetables at 0.5 parts per million. And now these vegetables may not have this particular value. But remember, it's not only vegetables that grow within these mine sites. other organisms forage there, live there, and so on and so forth. So they can have that potential to take up this cadmium, and it enters into the food chain. You can be asked to test what is the level. You are a biologist, you work in the biotechnological unit, you work in the agricultural sector, somebody asks you to test. Where is this problem? Maybe animals are dying. You now want to test. Has it really risen up? Before you conclude that result, you must subject it to hypothesis testing. That is the relevance of this. You cannot just say the mean value. Okay, let's take, for instance, the sample mean is 0.59 and the permissible limit is 0.5. You now conclude that it's high. Look at what I got, it's high. You don't conclude that. If you say that, they will ask you, have you conducted a test? What gives credence to the fact that you are saying that it is high? It's only statistics that will do that. You will not conduct tests. You don't conduct statistical tests. The procedure for conducting statistics is what we are learning. For you to conclude on any scientific data, for you to make assertion in science, you must be backed up by statistics. And that is the essence of this. Is that clear? Have I answered your question?
Yes, sir.
Huh?
Yes, sir. Yes, sir.
Yes. Yeah. So you mean on your undergraduate, you didn't use statistics in your research?
No, not that. I use statistics.
It's okay.
It's just that. Right. It's just that. Thank you, sir.
It's not this type.
No. It's just that when we are able to join you, you have already gone far because of some issues.
Okay. Well, this is not the first lecture.
Yes.
This is the concluding part of this hypothesis testing. We are moving over to experimental design by next week. Then I will conclude my session. Well, I noticed that we offered admission to about 70 of you, and a good number of you have not actually logged in for the very first time in this LMS. So we want to find out those who have our effective students, because they will ask us how many people have we enrolled. We can't even say. That is the problem. And I thank God for the course rep. He has asked us to fill a Google form. I guess that is a Google form. Please do well to fill. Let's know the number we are dealing with. Let's know the number. If I go with the number that's sat for that test as the real-time number or effective number of MSc students, I may be wrong, I may be right. So let's prove whatever. I will give you a second test, and with that second test, I will use that number to conclude the effective MSc students we have admitted. So please, let's take this program serious. Your friends who have been offered admission, tell them to log in. If you have any challenge with your login details or how to use the LMS, you can approach the center. You can take your time, drive down to the center, unless you're not interested in the degree, and get yourself sorted out with the LMS and join others and have their lectures seamlessly. I encourage you to do that, because by and large, by March, we may start talking about exam, or April, we may start talking about it will not exceed April. We must have our exam first week in April. So I'm not trying to raise alarm, but that is the truth of the matter. Please, let's take this serious. Thank you very much, and have a wonderful weekend. Yes?
Yes, sir. Yes.
Thank you for your time, Doctor. Of course.
Thank you, sir. What I want to solicit is, for those of us who maybe because of one or two issues, we joined late and have missed some test and quiz and assignment. Please, sir, I want to solicit if we can be pardoned in that.
No problem. No, don't panic about that. Okay, don't panic about that, but continue to be consistent with this training. Continue to be consistent with this training. There's a way we manage the class assessments. I have taken one, I will take another one. I believe that you didn't do the first one, you try and do the second one. You understand what I'm saying? And my colleague will also give a continual assessment. For every course, we take a mean value. We look at the activity level. Everything, whether you write your name here, whatever you do in the LMS, we note. Everybody records activity. My own activity, your own activity. How many times you logged in, things you have done here, assessments you've done, and so forth. We have all the record. Okay. Even you can also assess the recording of what you who have been listening to the recording of the lectures. That will also help you. Areas you feel you have omitted, if you logged in late, you can call up the record and listen to the lecture after the class. Okay, it's available in the LMS.
Okay, sir. Okay, sir.
So,
Thank you
in
very
absence of any other question, I think I'll have to draw the curtain and wish
Thank you very
you
much, sir.
a very
Sir,
wonderful.
thank you, Prof.
Just a snappy one. A snappy
Thank you,
one.
Prof.
Okay, go ahead.
All right, sir. So my question is, in the significance level, that is the degree of freedom, are we at liberty to go for 5% or 1%? What scenario can we
The
use?
question will
either of them?
direct you. The question will, depending on the risk level of the test you're running, but it cannot exceed 5%. 5% down, 5%, 4%, 3%, 2%, 1%, 0.1%. Anything above 5%, the test may not be relied upon. You have given a lot of room for error. The critical level, 5%. The essence of it that you're saying at 95% confidence level, you're relying on this result. In fact, experiments that deal with human health and all that, you cannot even use 5%. You rather use 1%, giving 99% confidence that you're correct, and this experiment is without error. You can confidently believe in the results you obtain. Is that clear? Did you understand that?
All right, sir.
So you're saying that you don't take any. Sorry. The question, I mean, for you conducting your own research, take for instance, you are the researcher. You set your critical level. Significant limit. How do you test it? How do you set it? That's what the question you ask, but not to solving questions posed to you. Question definitely will come with the level of significance. But assuming that you are in the office, you're carrying out a study, you're carrying out an experiment, you're asking, how do you set the error level? How do you set your critical level? I said it must not exceed 5%.
Okay, sir.
Is that okay? All right.
Thank you.
Thank you very much.